Drill down of problems facing the loops can be done by clicking the corresponding loop button in the loop status dashboard. This will take us to the problem categories dashboard for the loop that displays problem categories and their status through color codes of the buttons. Let us check the problems in Loop 1 by clicking and opening its Problem Categories dashboard. The Problem Categories dashboard lists some of the common problems that are encountered in control loops, and the status of the problem is indicated by the color of the buttons: gray for not evaluated, green for healthy, yellow for warning, and red for alert. The current loop name is displayed here on the top. We can see this loop has problem with oscillations as the corresponding button is red. Let us further drill down on the problem by clicking the button. We see a further classification of the oscillation source, aggressive tuning, and valve hysteresis. We can also see that the problem with Loop 1 concerns with valve hysteresis. Clicking the valve hysteresis button opens the corresponding problem analysis window. Note that the loop name is always displayed on the top. Right below is the problem status display area, and we can see red here as we have a hysteresis alert for this loop. Below this, we have several tabs providing the analysis results that support the diagnosis. The first tab provides data filtering options. Sometimes filtering of noisy data may be required to identify hysteresis. We have several options, both time domain and frequency domain, for the filtering. In this case, we do not have much use for filtering, and we proceed to the next tab. The Hysteresis Metrics tab presents evidence in terms of calculated metrics and plots to support the diagnosis of hysteresis. We can see that the hysteresis percentage estimate is above the threshold that was set as default. The oscillation index also exceeds the threshold that was set for it. The diagnosis is based on the rules that are provided by default. The rules specify thresholds for the calculated metrics and use logical statements. These rules can be modified or new rules formulated by the user for the purpose of diagnosis. The next tab, Supporting Information, contains metric indicators and plots that are useful in supporting and validating the diagnosis. For example, we can see the bicoherence plot shows high values indicating nonlinearity. That is a sign that the origin of the oscillations is probably not a tuning issue. Other information provided here include control error distribution, power spectrum, maximum bicoherence, nonlinearity index, OP reversals, set point crossings, and so on. The next tab provides plots of control loop variables and their distributions. This facilitates visual assessment of the loop's performance. The last tab provides the user the opportunity to plot any calculated metric from a choice of over 40 metrics. We can see that thresholds for healthy, warning, and alert status are defined for some metric, while others do not have any. The metrics that have defined thresholds are the ones used in the rules for the problem category. The users have the option to define their own rules using any of the metrics or their combinations. This section lists out interpretations of the diagnosis results and any suggestions for further action. There is also an option of inputting user notes for the loop and the problem that will be useful for the reports. To view the rules for the problem category and to edit the rules, click this button. This will open the rules input window. Here, we will be able to view, make, edit, and delete the rules for the loop problem category. Opening the rules input window, we can see that two rules are provided for the diagnosis of hysteresis problem. Both the rules make use of hysteresis percentage estimate and oscillation index metrics to define warning and alert status for the problem. The star next to the rules indicate that they apply to all loops in the plant. It is also possible to specify separate rules for each loop. Let us now add a new rule for demonstration. Let us say, if PV reversals per window is greater than 50, and PV oscillations are greater than 60, then alert. If this box is checked, this rule will be added to all loops for evaluating the valve hysteresis problem. Let's say we want to add this rule only to this loop and leave the box unchecked. Then we click Add Rule. Now the new rule is added to this loop and is automatically evaluated, resulting in red status for the rule. If the rule is not satisfied, the color would have been green. Going back to the custom metric plots and looking at the PV reversals and PV oscillations plots, we can see that the thresholds that we set are updated in the plots. Let us go back to the rules input section and delete the rule. It is possible to delete it either only for this loop or for all loops in the session. Since we have added this rule only for this loop, we leave this box unchecked and delete the rule. Now we can click Finish to go back to the problem analysis window or use the breadcrumbs to go to any of the previous windows. Similarly, the user can investigate other problem analysis windows. The application also allows users to new define problem categories and their corresponding rules. Another feature provided is the ability to change the status of a problem category for any loop, which is useful for post-processing. For example, if the user finds the diagnosis to be untrue, he can manually change the status of the problem and add relevant notes for reference. For example, we will change the hysteresis status to green and click Change Status, which updates the loop problem status as we can see.